This is the second part of lesson 1.1 in Foundations in Pre-Cal 10, talking about prime factorization. So the prime factorization of a number is when you take a composite number and you factor it into its prime factors, okay? And there's two ways that are generally done. One is you can do it using the tree diagram, which is probably how you were taught before. I personally don't like tree diagrams because they never end up pretty. I always end up having numbers hidden in the middle, and I have to, it never works out with your little diagram lines being as good as they are in the textbook. This is another way, which is using a division table, which is better, but I actually have so what the division table is doing is saying, well, 48, if I divide it by 2, I'm left with 24. If I take 24 divided by 2, I get 12. 12 divided by 2, 6. If you do this, it has the advantage of if you use the smallest prime that you can divide it by, you will end up with your factors sorted on your in order, which is really helpful later on. So let me show you another example. So if we do the table, we do 33,250 divided by 2 gives you 16,625. And of course, I'm just using a calculator for this. That's not even, so I can't divide it by 2. I have a poster up in my room, or I put it up in my room, about how to tell what things are divisible by. If something is divisible by 3, you can tell that if you add up all the digits and they're a multiple of 3, or you add them up again and they're a multiple of 3, then it's divisible by 3. But this is, so that would be 12, 13, 14, 15 plus 5, that's 20. That's not divisible by 3. So we're going to skip 3 and we're going to divide by 5 because that's the next smallest prime that goes here. And of course, anything that ends with a 5 or a 0 is divisible by 5. Throw that into my calculator, I get 3325, and if I divide that by 5, I get 665, and if I divide that by 5, I get 133, and if I divide that by 7, I get 19, sorry, oops. Ooh, what did you do that? Never seen that before. I don't know what happened there. Okay, I get 19. That was cute. And if I divide, 19 is prime, so if I divide that by 19, I get 1. And when I get down to 1, I'm finished. So these are my prime factors of 33,250. I'm not going to do the tree diagram because, like I said, I just think they're silly. I don't love this table. I'm just going to show you how I would do it. You can do it any way you want, but I'll just show you how I would do it. I would go, I've got my 33,250, and I just use a little line to say that if I divide that by 2, I get 16,625. So this kind of looks like a tree diagram that's kind of on its side. This just to me is more clear as to, like, this number gets broken into that and this, and then this number gets broken into 5 and 3,325, and then that's going to be, divide that by 5, I get 665. I divide that by 5, I get 133. Divide that by 7, I get oh, and then sorry, let me just clean this up a little bit. Okay, 665 divided by 5 is 133. And if I divide that by 7, I get 19. And I just tend to write it like this so that all of my factors are now in a nice, neat column, and they're all together like that. Okay, rather than put the 19 down here and then it's not the same place. Anytime you do prime factorization, it's a really good idea to just check your answer because it does not take very long. I've got 2 times 5 cubed times 7 times 19. Punch that into my calculator, and I get 33,250, which is what it was supposed to equal. So yay, I'm done. You can go and do questions 10 to 17. Bye.